So for questions 2, we have an object that launched horizontally from the top of a 50-meter height building, and the object seems to pass across a 30-meter vertical wall located 20 meters from the building. So we need to calculate the initial velocity of the object and the time taken for the object to strike on the ground and the velocity just before it strike on the ground. So this is a projectile motion, so I break it into x motion and y motions, whereby the acceleration for the x direction is 0, y direction is negative 9.81. The initial horizontal velocity is unknown, but we know that since from the questions very first the object is launched horizontally, so there will be no component y for initial velocity. Then as the object passes across the 30-meter vertical wall at that particular moment, the object actually already traveling downwards or drop vertically downwards of 50 minus 30, 20 meter. So it's already dropped downwards 20 meter and also moving forward as x 20 meter as it cross or pass over the 30-meter vertical wall. Okay, so in order to calculate the initial velocity, I need to calculate the time, so I consider the y motions. I use s equal to ut plus half at squared. So as it pass over the 30-meter vertical wall at that particular moment, it's already dropped vertically 20 meter. So I have my sy negative 20. Initially we doesn't have component y for the initial velocity, so uy is 0. Acceleration y is negative 9.81. So I obtain the time as it passed over this vertical wall is 2.02 seconds. So at that particular moment, the horizontal distance covered by the object is 20 meter. So I consider the x motions, so s is ut plus half at squared. So the horizontal distance traveled is 20 meter. So the horizontal initial velocity is the u that we want to determine, and then the time as it passed over the vertical wall is 2.02. So I'll get the initial horizontal velocity for the object is 9.9 meter per second. Then the second question, I want to find the time taken for the object to strike the ground. So in order to strike the ground, we are going to consider the whole entire 50 meter. As the object reached landing at the ground, actually the object is already moving downwards 50 meter. So again we use sy is uyt plus half ayt squared. We determine the time, so sy will be negative 50 meter. Uy is 0 because initially the object is launched horizontally. So uy is 0. Ay is negative 9.81, so I'll get the time is 3.19 seconds. So the last question, what is the final velocity as it strikes on the ground? So in order to find for this final velocity, I need to calculate first the horizontal component of this final velocity and the vertical component for this final velocity. So I'm going to use v is u plus at. So I consider the x directions. I find for the final velocity for component x. So because acceleration is along the x-axis is 0, so I'll find out that the velocity component x, Vx is equal to Ux equal to 9.9 meter per second. But for the y directions, our velocity, final velocity will change because due to the acceleration of gravity. So v is u plus at. So initially we doesn't have initial velocity along y directions. Our ay, the acceleration for component y, is negative 9.81. As the object strike on the ground, the time taken is 3.19. So we get the final velocity component y is negative 31.3 meter per second. Then now we combine the two components, so we will get the magnitude of the final velocity. When the object strike on the ground, it will be using the theorem Pythagoras, so I'll get 32.85 meter per second. Then how about the direction? Because velocity is a vector quantity, so how I find the direction? This angle where the object will strike on the ground, so I can use shift tangent, opposite divide by adjacent, so I take the Vy over Vx, negative 31.3 divided by 9.1, so I get 9.9, sorry, so I'll get the direction will be negative 72.45 degree. The negative telling you that the velocity is pointing below horizontal.